We're going to graph 2 cycles of the trig function. F of x equals 3 times sine of the argument of 2x plus pi minus 1. And a term that I haven't used, I don't think, is called the characteristic curve. Basically, since it's sine, the characteristic curve just means you're doing the dots here, the points, and drawing like this. And just recall that on the sine curve we have 3 dots on the center line. Okay, and then we go up 1 here and down 1. We're not doing a reflection here, but we're doing everything else. So we're going to take 6 steps and draw this. On the first page I'm going to write out the steps. The next page I'm going to do the graph. So I'm going to go back and forth with the graph. So the first step we're going to do is to step 1, and I'm going to just do it this way. Step 1 is draw the new center line. Now, let's go back. The new center line is your vertical shift here. This is your vertical shift. So we're shifting down. The whole graph's shifting down by 1. So the new center line is going to be y equals -1. So I'm going to go over here. I went ahead and started some of the labeling here. But normally our center line is at y equals 0 for the parent function, right? But our new center line is going to be at y equals -1. So I'm going to draw that here. That's where I'm going to start my dot thing. All right. Now, the next step, and I'm going to go back, step 2 is to find the amplitude. So the amplitude is right here. It equals 3. So the amplitude is 3. And what you're going to do is go to your graph, and from your new center line, you're going to go up 3 and down 3. So we're at -1. So this is going to be 1, 2, 3. We're going up to 2 here. Let's do it in purple again. So we're at 2 and go down 3. 1, 2, wait. This is 1, 2, 3. And this is going to be at -4. And I'm going to draw the line. Okay? So basically, we have drawn 3 lines. We have drawn y equals -1, y equals 2, and y equals -4. Whoops. Y equals oh shoot. It's right down at the bottom here. Y equals -4. So that's going to give us our characteristic curve, the boundaries of our characteristic curve in height, and where we start in it's the new 0. All right, the next thing, step 3, is find the phase shift. Remember, the phase shift is your horizontal shift. In this case, I'm going to go back, our argument is 2x plus pi. So the phase shift is actually the -c over b. So our c is our pi, and our b is our 2. So we have -pi over 2. So we're starting at -pi over 2. So the phase shift is -pi over 2, or we're shifting to the left by 90 degrees. So I'm going to go there and draw the line at x equals -pi over 2. And I haven't even filled that in yet, so how far did I go? So this is -pi over 2. And I'm going to draw a line, I'll do purple again, at x equals -pi over 2. All right, so that's where we're going to start. For sine, we're going to start right here and then draw your dot, dot, your points, dot, 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 point, point, point. All right, and this 3 dots here are going to be on this center line in here. Okay, this center line. All right, now step 4, we got to find the period. So step 4 is find the period. The period formula is 2 pi over b. Well, that equals the period. So that equals, let me clean this. So that equals 2 pi over 2. Recall our period is right here. All right. So 2 pi over 2, and that equals p. That means it makes a complete wave in pi radians, or you could say in 180 degrees. It makes a complete wave. This thing makes a complete wave from 0 to pi. So we'll come back here, and we're going to mark a distance. So we have to figure out where is pi. So what I do, and I don't know if I should do it on here or not. I'll do it right up here. So basically what I'm going to do is I'm starting at negative pi over 2, and I'm adding pi. Because that's where we're going to end, because since we're starting right here. And when I do that, I'm going to go ahead and write this as 2 pi over 2. And that's going to equal pi over 2. So we're going to draw the line at x equals pi over 2. This is x equals negative pi over 2. And this one is x equals pi over 2. Now, I had to make a complete step 5. Let me do step 5. Draw one curve. Okay, step 6 is going to infer the second curve. All right. So, if you notice, I really don't have any radians in between here. So, basically, I'm going to go ahead and I need to draw the 5 dots to get it. So, I'm starting here, and I need these midpoints in here. And there's a way to get the midpoints, but I think you should know that this is negative pi over 4, and this is pi over 4, because you have to label your graph. So now I'm going to draw the graph as a sine function. So I'm doing, I'm starting here at negative pi over 4. I go up here. All right. At 0, I go back down to my new center line. At pi over 4, I'm down here at negative 4. And then I go back to my new center line. I know some of y'all are going to have a problem with this if you're not very visual. I know some people that this is just so easy. They're very visual. So there is your sine wave. All right? It's a sine wave completed in pi radians. We started at negative 1, and our amplitude was 3. And there we have it. Step 6 is to infer the other curve. Since we already started at negative pi, since we're already centered here, I would just go to the right, and I would draw, label 2 more points here, or on the axis. So in between pi over 2 and pi is 3 pi over 4. And in between pi and 3 pi over 2 is 5 pi over 4. Because you have to label your graph. And then just graph from there. And you just do your dot, 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 whoops, doesn't go there. I always make that mistake. It goes here, a new center line, dot, dot, dot. No, it's kind of messy. It's hard to draw on this iPad with the graphs. And there's your two curves. The next video I'm going to do is the same thing, but with cosine, with 6 steps. Okay?